So I've talked about thermistors when you're doing temperature sensing, and they're basically you're measuring resistance. If you got down into the physical piece of the thermistor, it's not actually just a bare resistor, it's a semiconductor. There's another type of temperature sensor that you're going to run across. Same basic concept, it uses resistance, and these temperature sensors, whether it's a thermistor or the next one we're going to talk about, which is an RTD, you're able to just put a meter on the probes coming off of the sensor and get a specific ohm value that will correspond to the temperature in the room. RTD stands for resistance temperature detector, and they're specified based on ohms. So you'll have 100 ohm, you'll have 1,000 ohm, 5,000 ohm, and then the base metal that they're using. So that'll be platinum, nickel, there's a couple of other ones too. The one that you choose is going to be dependent on the controller that you're using. So some controllers want to see 1K ohm nickel RTDs, or they want to see 10,000 ohm thermistors. When you pick out a temperature sensor, probably the most important part of picking one out, other than the shape and the mounting consideration, is it going into a pipe? Is it going into a piece of ductwork? Is it hanging on the wall? Is it going to be surface mounted on a pipe so that you don't have to drill a hole in the pipe to sense the fluid moving through the pipe? Is the compatibility with the controller that you're going into. Extremely important to look at the controller first before you go pick out your sensors. Time after time, we just order sensors and the controller changes and we've installed all of our sensors, we bring them back and the readings are just way off. Turns out that particular controller will only accept a 1,000 ohm sensor and we put a 10,000 ohm sensor on it. So that's a critical piece. So if we have a controller that accepts both types, which one do we pick? So let's say I have a 100 ohm platinum RTD. That means at whatever the reference temperature is, it will be 100 ohms. At 90 degrees, it might be 110 ohms. And I'm just going off the top of my head. I'm not looking at a chart here, so I could be completely off. But it's that small of a change. So if I had a long wire run, because we're measuring resistance, my wire could contribute and cause some errors in my signal. When I go to a thermistor at, say, 10,000 ohms, there's a lot of ohms per degree with a thermistor. We're going to look at a curve a little bit later on here, and I'll show you what I'm talking about. So a longer run of wire doesn't affect the temperature readings that we see as much. There's a lot of play there. Thermistors are also faster responding than RTDs. Those are just some of the things that you might want to take into consideration when you're choosing a sensor. Another big thing might be cost. Typically, an RTD is more expensive than a thermistor. So in our typical HVAC application where we have 200 VAV boxes, saving $10 a sensor might come into play in the overall scheme of things. So just some things to think about. I keep talking about being able to put a meter onto one of these sensors to test it out. So let me show you how you would go about doing that. So I happen to have this Johnson Controls outside air temperature sensor. It's 10,000 ohm. It's a thermistor. And you can see it's got a weatherproof housing on it and a sun shield, so it's designed for mounting on the outside of a building. So when you're picking out sensors, those are the things that you're going to keep in mind. I'm going to go ahead and hook my meter up, and I'm just using jumper cables because I don't want to stand there and hold the probes. And you can see that my meter starts reading right away. I have the meter set on 40,000 ohms for my resistance scale, and I'm picking up 9,360 ohms. So 9.36 on a 40,000 scale. Now I'm seeing 9.35, so somewhere between 9350 and 9360. With a 10,000 ohm thermistor, that's not that big of a deal. 10 ohms is negligible, so I'm not worried about the resolution of my meter in this particular application. So let me warm this up by putting my finger on it, and you can see that the ohms are dropping. When you order a thermistor, you have the option of ordering it NTC or PTC. What does that mean? NTC stands for negative temperature coefficient, and PTC stands for positive temperature coefficient. Big words. What does that actually mean? The NTC type means, so negative temperature coefficient, all it means is that as the temperature goes up, my resistance goes down. Positive temperature coefficient means as the temperature goes up, my resistance goes up. Again, you have to go back and look at your controller to see what the controller is rated for as far as its sensor inputs. 90% of dealing with sensors is knowing what the controller can accept at its inputs. Extremely, extremely important. I keep saying this is important. This is important. It's really important. So now I have these ohm readings that I got from my meter. How do I make sense of them? First of all, I need to know what my sensor is rated for. I'm using a Johnson Controls temperature sensor. It's 10,000 ohm type 2 thermistor, NTC. So in the spec sheet, I have a little chart. You can see that here on the screen. The resolution that they give me for the ohms and the temperature chart here, I can't really find exactly what I'm looking at. So I found this really cool website. It's ACI Sensors. If you navigate to their site, this isn't a product plug or anything. It just happens to be very convenient. You can go to the temperature and you can grab one of their probes. And because this Johnson Controls sensor is a standard, this 10,000 ohm NTC is a standard, that means that any of the 10,000 ohm type 2 sensors will have the same scale. So if I look on my chart here, I can see that at 77 degrees, I should be at 10,000 ohms. That means that my room is warmer than that. But that chart doesn't really have it either. So this is the cool part. They have a thermistor curve, and it allows you to input some values. So I'll just put minus 40 to 200 and something. And then I can go down and choose the thermistor that I'm working with, the type. So this is a type 2. My Johnson Controls is a type 2. You can see there's some other options in the list. And then I want to generate a chart in half-degree increments. So I'll generate that chart, and I'll go down the list until I find something close to what I had. So I can see at 9,500 ohms, I was 79 degrees, and 91, I'm at 80.5. So somewhere in there, right around in that range, is what my room temperature is. So yeah, my house is a little warm right now. And that's it. And that's all you have to do to check one of these sensors out. Figure out the scale. So figure out what kind of sensor you have. Then go ahead and put your meter on it. Get the ohms value. Go to the chart, look it up, and then have a reference probe that you're looking at, a reference meter, something that's calibrated, and verify that the two numbers match or the two numbers are relatively close. If they aren't, then you just go into your controller and you make an offset change.